All right, so we are going to be finishing up our discussion here of three-dimensional shapes with finding missing dimensions from three-dimensional shapes. If you're given the volume of a three-dimensional shape, you can find the missing dimension, okay? Or you're given the height of the cylinder, you can find the radius, or if you're given the length and width of a prism, you can find the missing dimension, okay? You start with the volume formula, substitute in your known values, and then solve the equation for the dimension, the missing value that you were looking for. So it starts out very super simple here. You probably did this problem in 5th grade, okay? If the volume of this prism is 140 cubic inches, what is the height? Well, the length times the width times the height is the formula. So length times width times height is equal to volume. The volume is 140, okay? And so that means that 4 times 5 times height has to equal 140. And that's 20 times h is 140, so h equals 70 inches. Pretty straightforward and easy. All right, let's get a little more challenging here. The volume of this triangular prism is 1,848 meters squared, square meters. Whoops, cubic meters, that should be, of course. Volume, where Alex points out my mistake here. Cubic meters is volume. Okay, there we go, cubic meters. All right, so what is this missing dimension, A? What is this missing dimension, A? Well, the volume of a triangular prism is the area of the base, that's 1/2 base times height, times the height of the prism, which is the distance between the triangles, 22. So 1/2 base times height, or 0.5 base times height, times the height of the prism. Well, I know the base is 24, but I don't know what A is, so it's 0.5 times 24 times A times the height 22 of the prism equals the 1,848 cubic meters. Multiply all your numbers together, right? Everything except for A comes out to 264. So 264 times A is 1848. Divide both sides here by 264, and you get A equals 7, which means that the missing dimension here is 7 meters. 7 meters. I'm going to follow up with just a quick discussion of surface area because we didn't really do any video on surface area, just showed you one. So this is the most difficult of surface area problems that you would have to do, the triangular prism. So what is the surface area of this prism? Well, surface area is adding up all of the faces of the figure, right? So you have this triangle on the front and the back, need those areas, and then you have 3 rectangles. You have the bottom rectangle, you have this top side rectangle, and you have the top rectangle. Okay, this one up across the top. So let's look for the dimensions of all of these different shapes. So it's 5 different faces, only 2 of them have the same area, and that's the bases, the 2 triangles. So we'll do those first. The triangle is 1/2 base times height. 0.5 times 7 times 24 is 84 square meters. And there are 2 of those, the front triangle and the back triangle. 2 triangles, 84 square meters each. Then let's see what rectangles we have. Well, the bottom rectangle here is 24 by 22. Okay, so that's 528. 24 by 22 for this bottom rectangle. This side rectangle here, 7 times 22. That's 154 square meters. And the last rectangle is the top. So the top rectangle, oh gosh, the top rectangle, this one here, is 22 by whatever this length is here. So I'll call it C. Why am I calling it C? Because it's the hypotenuse of a right triangle. So we can figure out what this length is. It is not given to us, but we can calculate it by using the Pythagorean theorem. A squared plus B squared equals C squared. putting things together here. So 24 squared plus 7 squared is c squared. 576 plus 49, which comes out to 625. 625 is c squared. The square root of 625 is 25. So c is 25, which means that the final rectangle here on this, the top rectangle is 22 times 25, length times width, which is 550. The total surface area of the prism, rectangular prism, add them all together, 1,400 square meters. Okay, so I know you did a couple of these problems on the IXL. They were the annoying ones where you had to calculate all three different rectangle sizes. This one's even harder because they didn't give you the slant height here, and you had to figure it out with the Pythagorean theorem. But you're capable of doing that because we've learned all that stuff. All right, let's move on now to circular volumes, cones and cylinders and spheres, and finding missing dimensions on those shapes. So first, finding the missing height of a cone or a cylinder. This is the easiest of these. A cone with a 6-inch radius has a volume of 565.5 cubic inches. What is the height of the cone? So we know the radius is 6, and we know the volume, V, is 565.5. So we can substitute into the cone volume formula, which is 1/3 pi r squared h, or pi times radius squared times height divided by 3. So substitute in there 565, because I know what the volume is 1/3 times pi times 6 squared. I know what the radius is, and I don't know h. Okay, so all these numbers, pi times 6 squared divided by 3, I can do all that arithmetic in my calculator. That comes out to 37.7 blah, 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 blah. And you have to round this off. Well, to write it down, you have to round it off. To divide in your calculator, you don't really have to round it off because you can use the answer button. All right, so you do 565 divided by second answer, and there's no rounding at all. Okay, if you don't have that option, always go out at least one extra decimal place here than the answer is asking for. Okay, so if it was round to the nearest tenth, you should carry this out to at least 2 decimal places to the nearest hundred. Okay, but really the most accurate way to do this, if you use the pi button and then you use the answer button, then the decimals are going way out off the end of your calculator, and you'll get the most accurate response. 565 divided by 37.70 is about 15. Okay, so that's the missing dimension here is 15, and since the volume is in cubic inches and the radius was in inches, 15 inches is the missing height. Round to the nearest tenth if you had to. Okay, this one comes out obviously pretty close. So you can always check it by putting 15 back into the formula and seeing if the volume comes out correctly if you're not really sure if your answer's good. Okay, so that is finding the missing height of a cone, and a cylinder works the same way, except you just don't have the 1/3 in your formula, right? So that's pretty straightforward. The height of the cylinder or cone or height of a cylinder. All right, well, how about the radius of a cylinder or a cone? This is going to be a little more complicated. One extra step, if you think about it. So again, here's our situation. The can of pineapple juice holds 169.65 cubic inches of juice. And if the can is 6 inches high, it's one of these little cans, right? So 6 inches, yeah, I guess it's like a normal can. 6 inches high. What is the diameter of the can? So now I'm looking for this distance, which I don't know. But I do know the volume for the formula for the volume of the cylinder. Volume equals pi r squared h. I know what the height is, 6. I know what the volume is. I substitute those in. Okay, so 169.65 equals pi times radius squared times 6. Okay, I don't know what radius squared is, but I know 6 times pi. I can do that in my calculator. That comes out to 18.85, blah, 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 blah. Leave it in there, right? Divide to get r squared by itself. Now, it's not r by itself, but r squared. Can't do any more of that until I get it by itself. So divide both sides by 18.85, second answer in your calculator, and you get 9. R squared equals about 9. Well, R squared is not the answer. That's not the radius of this can. That's the radius squared. So at the end of this process, you have to do a square root, right? R, the radius times radius is 9. So the actual radius of the can is 3, the square root of 9. 3 times 3 gives me this answer. Okay? The last part when you're finding radius is sometimes the question doesn't ask for radius, it asks for diameter. So even though the radius here is 3, the diameter, which is what they asked for, is 6 inches, 2 times the radius. So be careful what the question is asking for if you are missing the radius or the diameter of a cone or a cylinder or a sphere. Okay, because all the formulas for all 3 of those shapes give you radius. They do not give you diameter, but you can always convert radius to diameter. All right, so finally, what about the sphere? So a sphere has only one measurement associated with it, the radius. So if I give you the volume of a sphere, calculate the radius. There are no other dimensions for the sphere, there's just radius. So the volume of this snowball, clearly a spherical snowball, 65.45 cubic feet. What is the radius of the snowball? We start with the formula for the volume of a sphere, 4/3 pi r cubed. Volume of a sphere, 4/3 pi r cubed. Now for spheres, r is the only dimension you have. So in these problems, it's always 4/3 times pi. It's always going to be 4/3 times pi. And they give you the volume. 4/3 times pi is 4.189. So if you're doing a bunch of these problems in a row, which you probably will not do, but it's always 4.189. Every problem is volume equals 4.189 r cubed. The radius is, the volume is 65.45. We divide that by 4.189. And that gives me r cubed equals 15.624. R cubed, r times r times r, equals 15.624. Well, what's r? Well, if r to the third is 15.624, then r is the cube root of 15.624. The cube root, okay? Now, doing a cube root on your calculator, different calculators have different methods for doing the cube root. It depends on what you have. Some of them have a cube root button on them. Some of them have a math menu that has a cube root in it. The blue TI-30 that we use, okay, the way to do that is the xth root, which this is common for some calculators also. So not the square root button, which is above the x squared, but the xth root button, which is above the caret. Second caret gives you this button. However, before you hit this button, you have to tell the calculator what you want x to be, because there's also such a thing as a 4th root, a 5th root, a 6th root. Okay, so you have to tell it you want the cube root by typing a 3 first. That's what this x is going to be. Then second caret, the xth root button, and then the number you want to find the cube root of. Okay, so it's kind of complicated. And with different calculators, it's really, I can't tell you how to do it on your calculator. You have to check it. Okay, so the cube root of 15.624 is about 2.5. 2.5 times 2.5 times 2.5 equals about 15.624. Okay, which means that 2.5 is the radius of this snowball. Okay, so that's the different types of problems you can get with missing dimensions of 3-dimensional figures. Given the volume, you can find the height or the base or whatever of prisms. Okay, you can find the height of a cylinder or a cone. You can find the radius of a cylinder or cone. You have to take a square root at the end. You can find the radius of a sphere by taking a cube root at the end.